And hello everyone, and thanks for joining to the next episode of Build on Serverless. We're building a serverless airline if you haven't seen it before, and today we're taking a break. We're not live coding anything, we're not building any loyalty service or testing anything. Today it's all about taking your questions, doing a recap of what we built so far, and answering any questions you have. Anything about serverless development is fair game. But I can't answer every possible question. That's why I brought a special guest with me. Julien.
Hi everyone, I'm not sure I'm going to have all the answers, so I'm Julien Lepine, been a solutions architect with AWS for nearly 7 years now. Been working in the dev space for most of my career. I'm super happy to be with you today.
Yeah, thanks for joining. If you don't know Julien, if you ever used Lambda in the past, for the past 3 to 4 years, I'm sure you have at least seen this project. So this is a project that Julien did, just to kind of make sure that you know he's a builder as well. He built a lot of cool things. This was actually something that was really, really important at the very beginning of Lambda, where sometimes you had to use Kinesis for streaming applications or DynamoDB streams, and you wanted to find out to multiple other places. So Julien actually built that was like 3 years ago?
Yeah,
maybe?
pretty much 3 years ago, yeah.
Yeah, and I remember customers using APAC and EMEA and even America.
Yeah, I have a few American customers that are still using it, pushing PRs, and actually using this fan-out project to get data from one source to pretty much anywhere else, other regions, other accounts, other services. Yeah, so pretty easy way to get connected.
Perfect. Any roadmap you want to share on this one? Anything that you would like people to contribute as well?
Yeah, because I'm working with a team now, ATOL being part of it. Haven't had enough time to be updating it, but I'm baking a new update with V2 that is going to be more modular, a bit more mature and modern, because some of it is still old Node.js code. So I'm going to be updating it, moving to TypeScript like we're doing for CDK, and actually pushing a few updates. But as soon as I have time.
Awesome. Okay, it's glad that you said TypeScript. I have something to show. If nobody asks about TypeScript development on serverless, I may actually just answer that question. I will have a gift for you at the end. All right, so what are we doing here? So let me actually show my screen, which sounds like I wasn't showing the screen anyway, so that's why you couldn't even see the project and things like this. So hopefully in a few seconds you should be able to see my screen. And the project I was talking about is called Lambda Fan-out. You should be able to see on my screen. You should be able to see on my screen. Let me see. Oh, I forgot to hit preview. So you should be able to see now. I can see on the task screen. So that is the project that I was talking about. It's under GitHub, AWS Samples, AWS Lambda Fan-out. What are we doing? So the first page you should probably know is this. It's our landing page to get notified about new episodes, but also gives you the full schedule. So far, we've gone until this episode number 6. Today is episode number 7. So from 1 to 6 is what we were calling prototyping. All you need to know in prototyping is I want to know the developer setup. What tools do I need to develop a serverless application? Do I need to build functions? What do I use? Do I need to test it locally? What do I use? So SAM CLI, Amplify, all that sort of thing. From episode 8 and onwards we use so many things, and we use lots of shell scripts as well, make files and things like this. But in production you want something stable, right? And when you get there, you want to see about integration testing, end-to-end testing, maybe.
And repeatability is usually a good one. How do I create a new environment? How do I promote? How do I separate my accounts? Yeah, usually key questions that people want to have good answers for.
Exactly. We were even talking about feature branches, deployments, and things like this, like a few minutes ago. We're happy to show you if you have questions about that too. And lastly, we're going to end with observability. And we also have a poll on the GitHub, which you can find right here. This is the main page on where you can find information about the repository. And there's one issue in here that's called bonus episode. In here, we're asking customers to give us ideas. What would you like us to do? So the last episode is on August the 7th. You actually are the one in control, giving us the guidance and say, if you have an idea, write them down in here. And then the number, depending on the number of votes, by mid-July, we will decide what we're gonna do. We've got ideas from building a mobile version of this, maybe Android, iOS. We got one was recently really cool. I think it's very valid. Is doing ETL for flights.
Yep.
And we're also getting things like, how do I do load testing? Could you do an episode on load testing? So this is your chance to actually add whatever you want in here. And we're more than happy to collect the votes and then build something exclusive for you as a bonus. All right, how does that application look like? If you haven't been to the first episodes or the previous episodes, you can go to, let me just zoom in here. It doesn't seem like I can perfectly. It's airline.serverless.dev. So serverless and my surname Lessa, so kind of makes sense, right? It wasn't me, it was Simon. So Simon, thank you for the click, the gotcha. So if you search for always London Gatwick to Madrid, every Wednesday there's going to be a flight until the end of this show. So if you click today's Wednesday, search for a particular flight. This is what we call catalog. You should be able to see a flight, add the flight, delete the flight, make changes to those flights. And we also have some filters in there. So you'll be able to filter by price or by schedule, for instance. We only have one flight, so it doesn't make much sense. If we click on that flight, we have an integration with Stripe. If you look at here, you're gonna see something like, let's say I'm gonna pay to myself. I'm from Brazil, any postcode, we're not making any validation. If you want to use a credit card, please use this fake credit card, 4242 at the end. Do not use your real credit card, please. Julian can expense that afterwards or something. So.
I won't.
And then you just add an expiration date and the CVC. Again, it could be anything. All he cares is about the credit card number. And once you say agree and pay, that will make a pre-authorization on this fake card. And you would kick off a process that will go async to say, I'm going to try to create a new booking. I'm going to confirm the payment. I'm going to reserve a slot and things like this. Behind the scenes, all of this kicked off a step functions that will look like this. Let's see if that succeeded. Right here. So it succeeded right now. So behind the scenes, all of that process, let me try to make it bigger. It's actually doing this. Because we said, I want to reserve a flight, it actually trying to get a seat for you. It creates a new booking, and then it collects the payment. Confirm the booking and send a notification via mail as well. If any of these steps fail, it will fall back to one of those processes, like refund payment and things like this. Yep. So this is called Saga pattern as well. I'm not sure if you're familiar, but essentially any transaction you have has to have a rollback associated. I think is the easiest way to kind of explain.
Yeah, I mean, compensating errors. It's nice to have transactions, but here we're speaking business transactions, not just technical transactions. So that's, quite an important one.
Exactly. So all of this you can see in the source code as well. You can see how we built all these step functions. If I go back to here, let's say I'm going to refresh this page. Now I'm talking to the booking service. It's the same API, but now we're talking to a different type of the data. You can see London 12th June, and I can see there's a preview of what the flight looks like. If I click in here, I get more details about where the flight is coming from. This is hard-coded. I still need to fix, but you get the idea. This is a booking reference. It's going to the right places. I could cancel the booking or check-in. Haven't implemented. Maybe we should invite Dave Walker and do some, how do we do check-in securely with, the right way of data, masking data out.
Maybe a good idea for this bonus episode to actually be looking at how do we secure and do we have a risk-driven discussion around booking services. Yeah, it could be a good one.
And I didn't think about this. So maybe if you're listening and you find that interesting, we haven't implemented the check-in service. When you check in an airline, usually ask you for passport information. We don't want to do the seat map. It's gonna take a long while, but I'm just trying to do
too much design. Actually.
I know,
way too much design.
That was a lot of effort. But still, you can actually do something secure around how you don't want to store first name, last name, everything into the database. You want to store some sort of a hash data or I don't know. I'm not an expert in that area, but we do have some specialists on the team.
Yes.
All right. And lastly, which we are still finishing up, is if I click in profile, I have access to what we call the loyalty. So basically, I can see my name, I can see where the status is, and a reference number. We're going to remove this, but still. And what I care is if I'm making a booking, if I'm going somewhere, I should be able to get points for it, right? Should earn those things. And I also want to know how many points do I need to go to the next step, right? And obviously here we have preferences. We haven't implemented, but I'm gonna leave this open so you can implement that yourself using Cognito, or you can just copy and paste some of the loyalty schema and do something similar. That kind of walk around everything we've done so far for the past episodes, and it kind of shows you what we're building, why we're building these things. All right, so let's see if we have any questions. Otherwise, I can walk you through the codes and kind of show you, Julien, how...
We had one question online, which actually we're going to be addressing, and that was an interesting one. Is so Danko wanted to ask if it's possible to continue using a project that we've started with Amplify. So and again, that goes directly to the next episode that we're going to be diving a lot deeper on, but maybe you have a bit of an intro on. I started with Amplify because it was easy and because it was super convenient to get started. But now I want to scale that and I want to get my hands on it. How do I reuse that and make it efficient?
No, it makes sense. So that's a really, really good question. So Amplify added support to what we call multi-environment, or basically you want to have multiple developers working on it. If I go back to the main project, I'm going to show you the source code and showing you why that works and how that works. So when you go to the project, you have a folder called Amplify. So if you're interested about this view, that's called Octo3 for Chrome, is an extension. Inside here, you're going to find something called team provider/info.json. If you don't have that file when you're initializing a new project, it means you're running an outdated version. Make sure you upgrade to the latest version and you have that file. That should be auto-generated for you. If you have it, let's say you create a new file, you just did Amplify in it. You didn't add authentication nor API, nothing. Just say you have something in there. Once you do, there's something in Amplify Console, which is a service that makes a deployment. What we do here is if we click in here, essentially that goes to AWS Amplify Console, takes a snapshot of that, and it actually deploys it for you. But because I deployed in separate AWS account, it will remap everything deployed on your AWS account and change all those files for you. So that makes it easier if maybe developers are sharing the same account, or maybe they're not. Yeah. Ideally, they should have their own AWS account, but we know it requires maturity. It's a different level of automation.
Yeah.
Once you get there, what you get for free is you get the project that looks like this, and because ideally you should fork that project, and once you fork it, you could create different branches, and as you create a different branch, you can go ahead and here and click Connect Branch. And here he asks you, what branch would you like to connect? I could click and develop, and then I could create a new environment from Amplify. So once I click create a new environment, for instance, let's say develop. And that will take a while to deploy. But once that's deployed, I can import whatever's been deployed on my account to my local laptop.
Okay.
So that's how you kind of works. We have documentation for this, but in a nutshell, that's how we do it. Make sense?
Okay. And how do I go, and that's, I think, the rest of the question, how do I go into changing something without using Amplify? I want to add something that is not supported by Amplify.
Okay, that's a really good question. So there are two ways you can do this. You have the hacky way, don't do this. And
it still works.
and you also have the way that we actually expect you to do it. So let me leave it here, and actually let me open up the repo as it was. I'll show you what this pull request means in a second. So if you go to the Amplify, there is a way, Amplify provides you what we call escape hatches, which is there are always going to be something that may not be supported by, or there's a feature that you don't have it. That's the kind of a drawback of being very opinionated. You get something really easy off the ground, really quick, but sometimes you want to do it your way. So when you get to that point, which we had to as well, inside the Amplify folder, if you click in Amplify backend, let's say you added a new API and now you want to customize that API with something that Amplify doesn't support. You create a folder called stacks, and in stacks you create a file called custom-resources.json, which that means you should have that file auto-generated, but anyway, you should have a CloudFormation that you can just do whatever you want. In previous episodes, we actually used this to add pipeline resolvers, which is a feature that if you make a mutation, process a booking, you should say reserve flight, call this other mutation, call this other DynamoDB, and that wasn't supported by Amplify CLI, so we had to do that ourselves. So that's how we normally recommend you to do it. The other way that you could do, which we have to do because we work with we're using Amplify CLI to deploy the API authentication, but we also use SAM CLI, which is the best way to deploy functions and other resources that if you wanted to. So the way we do this is we have an amplify.yaml. This is more advanced, but don't worry, if you're interested, you can go back to previous episodes and watch. Amplify.yaml file is the way you can customize the entire CI. So when this Amplify console runs, you can do anything you like using the latest Amplify and install Python, for instance, AWS CLI, SAM CLI, linters, anything you want. And because you do this, you can run this command here, which is a helper to do Amplify CLI push, but in a way that works in a CI much more friendly. And you can basically do anything you want. What we do here, we use make to deploy all of our SAM stacks.
Okay.
What does that mean? If I go to the make file, I deploy my API first and everything I need, but later I deploy both payments, which use a bunch of serverless components, and it also deploys the booking. And which we're now also adding is the ability to deploy the loyalty service. So that's a more complicated answer, but kind of touches you both ways that you can do. If it's something really quick and easy you want to do, use the custom stacks, custom resources. If it's something that's much more complex and you already have CloudFormation that you want to use, that's how we actually do right now. You can see we're adding a new stack called make loyalty, deploy loyalty, and also deleting that stuff. I know it's a long answer, but
it's good. Yeah.
we actually should touch both of these pieces.
Yeah, because it touches many points where you have your code that you're going to have to build and you have to execute. There's some CloudFormation and resources that you have to be deploying, and it's super important to keep everything in check because again, it's your app.
Exactly, and that kind of gives a hint. In 2 episodes, the next week we're gonna do integration testing and end-to-end testing. But on episode number 10, we're gonna start looking at CDK. And
interesting beast.
That's gonna be interesting. So we have to think differently once we bring in CDK, especially because CDK is not in GA. So we have to pin the version so it doesn't break once it goes GA as well.
Yes.
So use some of those techniques when you get there.
Yeah.
Awesome. Do we have any more questions, or happy to go through the most common questions that people ask as well?
There was this one that is a bit too specific for that stream, but we're going to take that offline.
Sure.
Are there any tips for speeding up deployments? That's a question that just came in.
Mm-hmm. So when you say speeding up deployments, do you mean CloudFormation or like stacks in general?
End to end.
Yeah. That's a great question. I don't have anything off the top of my head. I think CloudFormation takes its time because it does the rollback. It's a stateful. It checks everything that can go back to exactly where it was. If you are doing something like prototyping, for instance, you can just use AWS CLI to actually deploy those things and iterate that fast. I remember, I haven't used, so I'm not going to say vouch for anything. There was, I think it's called Brian. He created something called Arc, which I really enjoyed the idea though. It uses both SAM and at the same time uses AWS SDK to fast iteration. So it's called arc.codes, I think. Let me see. I think it's called arc.codes. Yeah, it's called Architect. So this tool, it's limited to a few services that you can see here. But what it does, it's really interesting. And I think SAM CLI maybe, I think we should add a feature request for that. But that's, again, just thinking how we could do that safely. So when you install this, you can actually do a normal Arc deploy. But at the same time, if you only change this function, for instance, or something else, instead of doing the full deployment, you can just change that particular function, as if you're going to the console and uploading the zip file. So I remember he posted on Twitter, and he was showing that instead of going in a few minutes, it takes like 10 seconds or something. Less than that.
Yeah.
Which is really fast.
Quite impressive. Yeah, because that's still in your CI/CD environment. You're still going to be updating a lot. So anything that speeds stuff up is interesting.
It's also tricky because at the end of the day, the more services you support, you also need to know how to roll back, how to go back to the stage where it was, keep track. If you're going to do a full deployment, does it drift by how much it drifted? So it's not an easy task.
Yep. Jay asked a question that actually is a great segue to some discussions we had earlier. What would be the best scenarios to use step functions instead of traditional lambdas? And that's actually a good segue on how big should your lambda be?
Sure, no, it makes sense. So let me go back and show you. So if we go to, let me go back in here. So we initially didn't even start with step functions. What we did was we used the new feature called pipeline resolvers, which I'm a very big fan of it. So there's something here on the left called functions, which you could create and say, for instance, this function should be able to reserve a flight. It would change the booking table, and it should be reserve a flight. Let's say reserve flight. Yeah. And essentially, you make a call to make, instead of a get item, I could just put an item and things like this. And you keep creating multiple functions, and you can do that in serial, right? Sequentially, in that sense. The challenge of doing this approach, though, and what we had, is if you go back to step functions, let me see where I had it. Here. If I open up the JSON and I show you the code behind it, that will make it easier. Like for here, for example. If I go back in here and I say, reserve the flight, if it succeeds, reserve the booking. But here I'm making operations against DynamoDB.
Yep.
Or I'm making operations against some other AWS API or some other backend. If that backend is overwhelmed, something's happened downstream, and you need to retry, you need to implement your own backoff. And you need to know also, if exception is X, then you back off. Or if exception is Z, and you back off by add 1 second, or back off rate, for instance. But if this exception is something else, you just fail altogether. When you try to do this using Lambda yourself, it becomes a little bit tricky, and it's difficult for you to make sure you have an orchestration engine inside Lambda. And if you're doing this, you're paying for this as well.
Yeah, and it's a usual example that we have with customers on discussing Lambda implementation of step functions. Is that if you could do everything in Lambda, I mean, you can get up to 15 minutes, so obviously you're going to be able to run everything. But basically, you end up writing in Lambda a huge amount of boilerplate code that is not providing you any business value. All these compensation mechanisms. If you do that in a Lambda, basically just throw an error when something goes wrong, and step function is going to handle everything for you. And you just focus on your core business code, which is how do I reserve, how do I pay, how do I integrate with Stripe or other providers. If you want to do that in a Lambda function, obviously you could. But again, what would happen if Stripe took 5 more seconds to answer, or actually they want to add a new payment mechanism and something? You would basically end up updating and updating and updating the same piece of Lambda code that basically for maybe 15 lines here, I mean, just if we take just this example here, we may have 20, 30 lines of actual code that does something. It's not a lot of code. If you want to have all the boilerplate that actually does everything in Lambda, you're looking at hundreds of lines of code for exactly the same feature. And when you end up building all these mechanisms and compensation, that's usually when you say, actually, I should stop it and move to step functions.
Yeah, actually, let's show that in practice. So if you go back in here, and you can see the step functions is handling for us all of the transactions that's happening, when it started, what was the last time, how long it took, including getting access to the logs and to the Lambda function. If we click into the reserve flights, I'm going to zoom in a little bit before you say anything. And you should be able to see input and the output of each of those, what the exception was in case something happens. If I go and look at the code now, how simple it is once you have that step functions clearly defined in JSON, actually looks like this. Let me go back and find which tab I had. So let's take the payment first. If you go to source, backend, payment, I can click in source and I say collect payment. It's just a Python file. And I have an event.json that emulates what the event actually looks like if I were to do it in production. So I can prototype. When you look at here, all we actually do is we have an exception called payment exception. And we use that exception to know if something went wrong and how do we handle that inside the step functions. And the function itself, it collects the payment. The business logic is really that simple. We actually make that post. We make sure if it's not 200, and if it is, we just return a payment exception. Otherwise, here's the receipt URL. And inside the Lambda function, we're just checking for the basic validation, and we're just returning. That's nothing else. It's really that simple. Most of the lines are actually doc strings.
90% of the code is actually comments.
Exactly. And if I open up my Visual Studio Code and show you what that looks like from JSON, so we're looking at collect payment, right? So collect payment, at the moment, you will call this Lambda function as we wanted, and it has a catch in here, which basically says if the payment exception was the error when it tries to invocate, so add that payment to the error and move to the next one and just stop it. Something else went wrong with Stripe, and the next step would be cancel. Or in other areas, sometimes you have an exception, for instance, which is throughput, service DynamoDB limits or request limit exceeded. Instead of going to the next step, what you could also do is saying, how many times do I retry this? What is the interval in between? What is my backoff? Yeah. All of this is like 10, 15 lines or even more in Lambda.
That's a lot of time, and because you want to have randomness in your exponential backoffs. And there's a lot of stuff that has to be baked in, and we actually have some nice blog articles in the architecture blog that explain how to do exponential backoff. Everything's baked in. You don't have to do anything.
Yeah, exactly. So that is one of the reasons why we would prefer to do it that way. So if I actually
before you leave your definition of your step function here, if you can get it back on your JSON, if you go up on the Lambda functions that you were executing, there's two interesting elements here. So obviously we create a task. There's a keyword that is important, that is the result pass here in the definition of the step function. Anytime we have an output of a step function, instead of overriding the input, we actually add stuff in. That makes always the document bigger, so it makes it interesting. When you look at the resource here, we call directly the Lambda function ARN.
Yeah.
So we have ARN :Lambda, AWS Lambda, region, account ID, function, and the name of the function. A few weeks ago, actually a couple of weeks back, I would say, the step functions team released a major update of step functions that solves what for me were two huge issues for step functions. The first one I was discussing with the PM the day of the release of step function around it is, for Stripe, we're pretty happy. We're pretty easy because we call an API and we have a callback. Sometimes we have APIs that we have to call, or we have human workflows that we have to call, where we have to wait for feedback. And up until this update, which we call the callback pattern for step functions, basically what you had to do was make a pause in your element by creating an activity. That's actually a new JSON stuff that you create an activity. This activity would receive a token, and then you would have to create a Lambda function or create what we call a poller, an active wait. It would actually wait for that token to be responded to actually keep on continuing and going with the Lambda function, or actually with the rest of your step functions, once you have the feedback. So that's a lot, again, of boilerplate code. With the callback pattern, what you can do is actually say, I'm going to store that in DynamoDB, or I'm going to use SQS and actually send that token to SQS. Or I'm going to call a Lambda function with a specific token that is directly provided. And that token, I can just directly call the step function API, and just say, here's the token, off you go. And with exactly the serverless application that is presented by Aitor, you can actually do that as if you were doing CFN type callback. So super easy. And I've just changed. I'm going to be publishing a series of blog articles around another serverless app around CDK, where I've changed all my workflow using the callback application. It just drastically reduced the amount of code that I have. So that's the first one. Just really all these patterns where you had to either have podders, using CloudWatch events to get Lambda functions that would run on a regular basis and stuff like that. You can basically remove all of that and just go to the callback pattern. Please look at it. And the second one is actually the first question. So part of the question that we had with Aitor is, how big should your Lambda function be? If you do the integration with step functions the way we're doing it, which is, I would call that the legacy way. Don't tell the service team that I say that, but that's definitely the legacy way of doing it. So basically just using the ARN, you don't have a choice to actually change the input. when you have a step function or a task that is described, the input is going to be your whole blob. You can have input paths that will select a specific part of the blob, but you can't change it. And you can't modify the payload specifically for your Lambda function. Which, as an outcome, means that if you have 4 Lambda functions that need to be run, usually you're going to need to describe 4 Lambda functions, even if actually in the backend it's pretty much, it could be the same code that actually just has different entry points, like we would do with routings for APIs. With this new feature, you can also call synchronously and modify the input. So with the same code, like let's say you have an API, you have a step function that is doing some code using a Lambda function, you can actually tweak quickly the payload, adding some data, adding a name of a function. So in terms of deployment, instead of deploying 5, 10, 15 Lambda functions, you can actually have one Lambda function that is going to do the core and like the common stuff. And when we're speaking about CRUD type deployment, where you have one table, it actually makes sense sometimes to have all the code that is just touching that table in one single file. Because it just makes it easier. And using that, you can basically have one Lambda function that's going to be called with different parameters by step function. That simplifies again the deployment. And to get back to your question, that's going to actually speed up deployment because it's one Lambda function to be deployed. So these 2 features of step function for me just drastically changed my experience of step function. And it's going to be integrated into CDK soon because I was actually commenting on that yesterday evening. So callback patterns that we have for step functions, amazing work that has been done. And the same with the integration, the new integration. Again, simplification of your code.
Yeah.
That's always good.
No, absolutely. If you're interested on this new pattern they just released, I think it's like 2 weeks ago or something, this is the documentation page that you can find. The link that I was showing before is work from the serverless hero Ben Keyhole. I really need to learn how to pronounce that surname. I think it's Keyhole. But don't worry, nobody can speak my first name right anyway.
Yeah, so he's actually the head scientist for iRobot.
Yeah, he's a genius.
He's quite amazing. So he's behind everything that is done with inside iRobot, and he's the head of IoT and automation and tons of stuff there. Amazing.
Yeah,
guy.
I don't know. Ben has a super interesting title, cloud scientist.
Yeah,
he's like, why would you argue with him, right? But now I have Richard Boyd as well, who helps a lot on this show. So thank you both of you. So you mean a lot to us. So the documentation page is over there. You can find out. And back to the questions on how big should it be, etc. If you go back to here, you can see that one of the best practices we follow is the Lambda function per se should do very much almost nothing. It's very dumb. All we're trying to do is something specific for that Lambda function. What we know about the event. But all the business logic is actually a separate function, which again could be a separate file and yada, yada, yada. If you wanted to do something else afterwards, or if you want to use ports and adapters or clean architecture, that would be the way to go. Don't try to add all your logic inside the Lambda handler. It's fine to start with a single Lambda function. If you feel more comfortable with middlewares like Express or Java Spring, by all means, go for it. But don't think that this is actually the long-term road. Using frameworks like this or middlewares like this, it doesn't help you with the mindset of thinking on single purpose function. Or if you want to start deploying something that similar to CQRS, for instance, where you want to make sure that certain parts of your business have more concurrency, or you have specific metrics or different performance goals, for instance. So you can find all of that in here already. Loyalty, we're still building. Catalog, there's a few things to finish, but the booking and the payment's pretty much done. And the next phase, this phase of this show, for the next episodes, we're going to be changing that to add custom metrics, structure logging, alarms, and all of that stuff in there too. All right, cool. Any other questions?
So there was actually Dan coming back on saying, so we can actually combine Amplify and SAM and others in the same project.
We can, and actually that wasn't the reasons we want. We not only do this, what we also do is we combine also AppSync with REST. We do GraphQL and REST too. It shouldn't be a binary decision. Let me show you how. If you go back in here to schema, for instance, and we're actually writing right now, I think I just pushed on the pull request. There should be something here called loyalty. Here we go. I have a loyalty and I have a new query called I'll go back here, query, and I have a new query called get loyalty, and I don't have any resolver. Instead of calling a DynamoDB or Lambda function, I could actually call another API gateway or another service through HTTP, and I can get a return and still get the power of GraphQL. For instance, I can select only parts of the results I want. So that's how we could also do that from the outbound. You could also add API gateway in front of API gateway, for instance, upsync. Before upsync, most customers were using API gateway in Lambda, and they were running GraphQL server in Lambda.
Yep.
That used to be a very common pattern before AWS upsync.
And there's been an update, again, I hope I'm not taking you off guard here.
No,
there was a key update that was released, I think a couple weeks ago by Chris, that was announced by Chris, on GraphQL, the ability to actually call Lambda functions directly as a binding from your AppSync description.
Yeah, it's actually, if I go to Amplify GitHub documentation, I think it's this one here. So basically, inside the Amplify CLI, you can add what we call directives, right, in GraphQL.
Yep.
So if I go back in here and let's try to bring this. So I have the GraphQL schema right here as we speak. So I use model as we spoke at the beginning to add a DynamoDB, but I could also add a @, function in here to call Lambda function. Instead of calling DynamoDB, I could call Lambda function, and I can manage that separately, or I could also manage that as part of Amplify. So if I search for function, there should be, maybe I'm actually in the wrong documentation. I'm sure I am. I know there's a function, function. Let's see. Maybe it's not here yet. Don't know. There's I know another Dabbit. Let me go another Dabbit function Amplify. He posted, I think it was this week or something really, really soon. I'm not sure if I can find it quickly here on the spot. So introduce React, let me see. Maybe he posted on the Hacker News or something. Another, if you are here on the chat, please post a link to your blog post. I saw that on Twitter really recently. But you can use @Amplify CLI function. Let's do some Google foo in here and see if it works.
Function directive.
Yeah, exactly. So we added in here, but I don't know because I don't think he was on. Actually, I think here we go. Sorry, my bad. It's actually this, and also I found another one now, but now forget about another. Not forever, just for now. So in this blog post by Kurt Kempel, so I was wrong, it was Kurt actually. We introduced two things. For me, Lambda functions is great, but what I'm really passionate about it is, which we had an experience with building Zerline, is when you do a @ model, you create a DynamoDB table, create, update, read, delete. But what if you want to add an index? Yeah. You had to fall back to CloudFormation and create a global secondary index. Some stuff that you are more familiar than I have. But now you can do @key, which you can add functions in here. But there's something really cool. Let me see if I can find an example in this blog post. What is it? I can find out. Here you go.
Atkey, yeah, we have it here.
This is so awesome. Like, essentially, you basically can keep changing your access pattern on the fly without knowing anything about DynamoDB. So you can, for instance, you can add a new index and search by email, for instance, or you want to search by order ID and create an @. And you just keep doing this without knowing all of this, behind the scenes of DynamoDB, how to do it properly and things like this. Or you can even say, I want to create a new key on those particular fields, and the way I want to use the query is actually by doing this. And it just keeps creating a new query, and he leverages the power of this. For me, that was like game changer. Adding a functions, it should be somewhere here, but I really loved this key. Here we go. If you add a new mutation, you can say when you add a new entry, instead of doing DynamoDB directly or something else, you can specify the name of the function.
Yeah,
exactly. But key for me was just like, oh, that changes the game again.
Yeah, again, it's the usual object relational mapping type discussions where if you go directly to your database and actually you push back to your clients directly all the logic, and here you finally get back at the server side, still behaving in a serverless way. That's super important. You don't want to be deploying machines and EC2 fleets and managing them. Believe me, it's not the most fun. Here you can really leverage the serverless capabilities and getting back on it.
Okay.
So there was a question from ZEB's Arc, stepping back. Nice pun, by the way. What capabilities do we have to sign the code, proving that miscreants have not modified code since it was deployed on GitHub? That's actually a nice question that everyone should be asking themselves. So as a manager of a security team, I'm not going to dive deeper too much on it because they're going to hate me for that. But no, I mean, one of the key points is anything that is on GitHub is as is. So it is really your responsibility to think about security. And again, maybe go to having the August 7 episode with a bit of security. We have a few key people that are super deep on how to secure these environments. But yeah, obviously you want to be signing, you want to have organization, you want to have maybe a fork of the repo as it is on GitHub and actually managing security locally. So there's tons of best practices you want to be using. And security has to be end to end. So it's both the code you're going to be running. So here we use GitHub and a public repo on GitHub. Obviously, if you have a business critical application, you may not be pushing that and opening that to everyone. So you're going to have to make sure that you do that. There's other services such as Code Commit that actually provide an internal only secure environment that is linked to IAM. So there's many ways to do that, but then the rest of your process has to be hands-free as much as possible. So everything that we're doing by hand, that's actually a risk by itself. So you wanna make sure that you have the best practices for developing, deploying, and operating using a multi-account environment and actually allow security around it. So yeah, it's really focused on security end-to-end, not just code signing. It's still a big part of it, but yeah, really focus on the broad story here.
Mm-hmm. Absolutely. It goes back to some of the questions sometimes we receive about how do I make sure that my developers are not adding anything suspicious in the code? How do I make sure that they don't do X, Y, Z?
Yep.
Some of it is actually you can automate into a CI/CD pipeline. But in reality, for large enterprises where you have hundreds of developers or thousands even, it comes down to processes. I mean, you have to have the culture aspect embedded and making sure you have security code review. When you go to serverless, security it's no longer the fact that you have to buy an appliance to make sure you get your checklist and say, oh, it is secure. Now the security job changes a lot and get much closer to the business logic as well.
Yep.
And making sure that you do security code review. It's a process that takes time, but it's actually it's a very interesting journey when you see customers moving to that direction. Everyone becomes agile and more importantly, becomes more secure. You see serverless folks using Lambda functions to automate lots of things on AWS.
Yeah, and you have to look at all the roles that you've been creating. One of our colleagues, Ken, has submitted the Media to Cloud solution that is available on the AWS website. Again, available on GitHub, full serverless. Takes your media on-prem and actually moves them to the cloud and does indexing, machine learning, all kinds of nice features around it. Mm-hmm. And before we publish that, and on a regular basis, inside Amazon, we also do security assessments. And you can go to pretty great lengths. And key point to think about is how secure are your IAM roles? And especially if you use Amplify and stuff like that, do you have Lambda functions that basically can do store on DynamoDB :star, basically do anything on DynamoDB? Yeah, that may not be the best practice for that. So again, there's a few good practices, and I'm always going to get back to Aitor's serverless lens for well architected. So there's tons of best practices to ask yourself around how secure is my posture. So it's around data at rest and in transit, encrypted, secured, or even hashed. Sometimes you don't want to have the data. We have Stripe integration for payment. You don't want to store credit card information. Let them do the job. It's a different job. It's really a craft that you have to master. So maybe just a hash of some things that will just make sure that you store enough information to be confident that you're going forward, but actually not enough to actually put you in a state of trouble.
Actually, let's show that in practice. If you look at the highlight right now, you see that there's a function called confirm booking. We have a policy that says, I want you to do a CRUD into the booking table. And that will generate all the permissions we need specifically for that table only. and it stops right there. If we go to when we need to make a booking, we need to know what the customer is. Otherwise, how are we going to retrieve that, right? And how do we do this? We don't. If we go to the booking one here, now that I have too many feature branches, so let me go to the switch branch. So every feature branch actually deploys the whole stack again, so it makes it easier for me to prototype. If I click in the booking one and I see I have a new booking that we just done right now, let's click this one here. Actually, this one that I just did. You're not going to see my name or things like this. What you actually see in here is a customer ID, which basically is the signed in ID when I signed in from through the airline. So basically it's a cognito unique ID from my customer. If I really need to get information about that customer, I can actually get there. But my front end, once it signs in, the customer itself can see attributes of it or things like this. Otherwise, I don't need any of that. And more importantly, remember that stack functions that we've also done? We also know exactly what state machine, what was the execution ID that created this new booking, so we can trace it back if we wanted to.
Yeah.
Awesome. Okay, so I have a few 10 more minutes. Any more questions that we want to surface?
A lot more directly on the chat. So if you have other questions, please go for it.
Okay. So I actually put together a few questions that I thought, in case I thought people wouldn't, ask. Let me go back. I can find out. So we touched the single purpose function already. We kind of touched how to manage large serverless project. Now you kind of have a make file, you have all these pieces. This is a very common one. This is like, you only see that when you start growing from a single, Amplify CLI is unlikely going to see that. Everything's very tight, everything's very handled for you. But as soon as you start growing into booking stack, a payment stack, and how do you share that table? How do you share the URL so the step machine can actually, the function that get called by step functions can call back to Stripe the payment API.
Yeah.
How do you share those things in the first place? Let me show you. Going back in here, you can see there's a make file in here. The make file, let's say I want to, because the step functions is part of the booking stack, I want to make sure that once I deploy the booking, first I need to deploy the payment. Once I deploy payment, I can deploy booking. In the booking stack, I have a bunch of parameters in here. Let me zoom in case you can see it. We do two tricks in here. This only happens if you're using Amplify CLI and SAM. Because Amplify CLI is managing the DynamoDB table, the at model, we don't need to do a describe stack and trying to find out what the DynamoDB table name is. No. We have all of that local already, so you just parse the JSON. A bit of a JQ kung fu, you should be fine. But also, we do something that it really took me a while to get that pattern in place, especially when I was used to use just parameters or import, export in CloudFormation. We can say this is the function, and we pass a /service /payment, and we also pass the branch. First, look is like, what is happening here? There's something wrong in here. And we also pass the stage. We need to open up the SAM template so you understand why we're doing what we're doing. If we go to the source backend booking, we open up the template.yaml. You're gonna find something really interesting that we call out in the serverless architected or serverless application lens, which I can open up in a minute. We use the stage to create any particular resource that has to be specific to a feature branch if we wanted to. That way we have a single template instead of creating one template for that, one for prod, one for something else. But this is the magical piece. Step functions, not step functions. CloudFormation integrates with SSM System Manager Parameter Store. I could have CloudFormation to automatically fetch the value that it is already in there. Or I can pass a default parameter name, or I can pass the parameter name, and CloudFormation would go fetch that for me and use the value as I need to use inside my step functions. That's why I see the out expanded. Yeah. So that way I don't block my stacks by using import, export. I don't chain them, but I also make it free if I want to make more other parameters exported. The same goes if I go back to the collect payment so you can see the publisher side of things. This is what we do in every stack. Inside the payment stack, we also have stage. But we see that after we create the functions, we have the same name, but we append a suffix code. Append the suffix doesn't make sense, but my English breaks sometimes. You have a parameter there.
I'm French, I'm not going to complain.
And then you have on the line 48, you have a /service/payment/collect functions. And you have a stage in there, which means every feature branch will have its own parameter, its own value. If you want to prototype that locally, I could also go and fetch what the value is and target directly that if I wanted to. How does that look? If I go to parameter store, I have a bunch of those in here. You see service, booking topic, process, state machine, endpoint URL, and all those sort of thing. The collect payment that we are talking right now is actually here. We can have the all earning here, which is exactly the one we were showing before in the step functions. If I refresh, I should be able to see more in here. Because I just deployed no, it's not deployed yet. So I was trying to deploy a develop stack, but still kind of give an idea on why I failed.
Yeah, what parameter store does here and makes it, no one's seen it. It went red, it failed. One of the key points that parameter store fixes here is that if you have multiple stack and multiple environments and stuff, one of the ways that CloudFormation allows you to do that is stack experts are basically going to have cross-stack references. That works super fine.
Yep.
By the way, there's no questions asked, but when you start using Amplify or others, because the tooling is built around this idea of having small environments, if you start having these experts and dependencies between stack and stack sets, you're basically breaking the tooling that we have that makes it opinionated, super fast, and really easy to use. Parameter store is actually a super easy way to get this central store because it's in it. And instead of having to break and put something around your Amplify elements, you just put something in. It's really 4 or 5 lines of CloudFormation code inside of it. So super simple, super fast, but at scale in enterprise architecture, maybe you would want to use actually CloudFormation stack and stack experts and dependencies and stack sets. But again, it's a different discussion from what we're having here.
Yeah.
In this case, parameter store is just super easy and convenient.
Exactly. The paper you mentioned over here, Serverless Application Lens, is what we wrote based on experiences, and we refresh that every year. Basically, it's also both the best practices we have around serverless. How do you deploy across multiple accounts? How do you secure functions? What are the questions you should ask yourself before you go to production, during production, or even actually after you deployed? Maybe you want to check on the monitoring, the metrics, and all of those questions are there. What we're discussing right now, it's actually part of the operational excellence pillar. If I keep scrolling here, apart from the metrics and tracing, which we're going to be calling in the next episodes, you see there's one in here that says, how do you evolve your serverless application? And all of that shows how we do multiple deployments at the same time using aliases, which we're not using right now. We will, kind of a sneak peek.
It's a hint.
Yeah, exactly. But it shows you the services you can use, how you do safe deployment. So it's a lot more practical white paper compared to a more generic or research white paper. It's more about questions. How do you do this? Here's how you can do. Here's some best practices. And also, here's some questions, here's some resources, links, in case you haven't seen it. Yep. So that's the white paper. We have 5 minutes left.
I have a question coming from the chat. Actually, Cheng asking, if I want to achieve a function that actually holds an order, so let's say I'm an airline, and like most airlines these days, either you pay for your ticket right now, or you say, I want to have the option of holding for 24 hours. So I'm not paying, I'm not booking completely my ticket. I'm just holding that ticket for 24 hours.
Okay.
How would you do that?
Actually, I was thinking, I know an easy way to do it, but maybe you can correct me and find a better way. Let's go. So if you go to the step functions in here, we have a bunch of tasks in here. The step that collects the payment. First, we do an authorization. If we want to charge the customer, that's where we charge. If we go back in here, and if I click in collect payment, I should be able to see in the output. I remember that I should have a receipt URL. So that is the task that actually effectively charges the customer. So I can see I was charged €1 because again, it's a sandbox account. Always going to be €1. But if I wanted to wait, step functions has a wait state, which you could actually wait up to a year. It doesn't mean customers want to wait for a year for something to happen.
Maybe a bit,
but it's something that you can do. So if you look for step functions wait state, you could actually wait for a predetermined amount of time, be that static or actually dynamic. So the way that works is we could say exactly this. We could append this before a task before we go to payment, and we could do like this. Or we could have, again, a callback pattern. Maybe we could
Callback pattern is exactly the best one, where you can basically ask Lambda to start the process, and if you go back to your step function definition, basically you do the first two steps that are booking and reserving. So reserving the flight, reserving the booking, and before going to collect payment, actually, you could have a callback pattern. On a callback pattern, you can ask and you can add a timeout seconds. It's 99,999,999 seconds as a maximum value. So that's quite some time to wait. So I think that's gonna, booking, the plane is gonna leave way before that. But actually you can just, start with your callback pattern, put a timeout seconds. Task is gonna wait until you provide it. And so basically you put that in 24 hours. 24 hours later, if no one actually validates it, by just calling step functions, send task success, simple API call to get that. If the customer does not call that function, so basically finishes their booking, then you just automatically cancel it and you're good to go. And you go to the compensation, which we have already. Cancel booking, release flight seat, and off we go.
I don't remember. I haven't seen that. I haven't tried callback patterns yet. So on me, I need to spend some time in doing it. But I used to do activities, if a polling would fail, for instance, let's say that step functions will send you a token, and you fail to proceed. Maybe it was an EC2 or on-prem service that dies and nobody knows what it is. And if you don't return, can you add a heartbeat in step functions for activities for callbacks as well? Maybe
Not
you can.
that I know of for callback. Maybe you could. If you want to have, and specifically if you're calling an on-prem service, I would actually recommend you to use an activity still. Because activity is way more defined on, you can send a heartbeat, and then you can basically set your timeout and in the meantime just send heartbeats. You can send success and you can send failure. So in your case, which is I'm waiting for an on-prem service, I would actually still go back to an activity because you're clearly defining something as being an on-prem activity. If you go to task, actually you're going to have the
Here we go.
definition.
So there's a timeout and a heartbeat. I don't know if that works for callback. Maybe it does. If anyone from the step functions team is here, that's your opportunity to help us and understand that. Maybe it is. I don't know. But it's something that I remember actually being stuck with activities in the past where I had an exception. It was just, as usual, the comma or something.
Usual ones.
1 more minute to go. Anything that you want to pick? Anything yourself? Want to ask anything or want to share something?
It's a super fast moving space, and I've personally been having a lot of fun, and we've been discussing around it with CDK as well. And I heard that Simon and Lee are looking at CDK. So it's definitely a super fast moving space and an interesting one. Watch out for anything that is coming. And everything that we've built here, we can basically run that with a 10 or couple dozen lines of CDK construct. So watch this space when you start with Amplify and actually want to release on a more CI/CD fully managed manner. Actually, CDK could be an interesting one to go through.
I really want to see how I can use CDK and Amplify CLI. I think what Amplify CLI does for adding authentication with Cognito, adding the GraphQL and the transformers, this is unique. I don't think CDK will get into that space, but I think CDK could do something I want to do. I'm thinking on GraphQL schema stitching or schema federation for deployment across a large number of teams. Maybe we could do that with CDK. Stay tuned. On episode number 10, we're going to actually look into CDK and see how we could revamp some of the infrastructure we have and make it more declarative and actually improve that. Because Makefiles are great. Like I said, prototyping, you need something really fast, but it may not be the best choice for something that's more stable in the long run. Right. For those of you who are actually helping us and asking the questions and all that, we more than appreciate you having the time and actually helping out, asking the questions. And I could look at the chat and I was like, wow, I wasn't expecting to have all that the activity in the chat. So I really appreciate that.
No, it was super cool.
Yeah.
Thanks for having me. Thanks everyone for watching. It was a pleasure.
Yeah,
you
always.
soon.
You can always come back. Maybe you
Yeah.
can, maybe you can do the bonus episode or something.
Yeah, I'm going to do an episode and dive deep on CDK. I'm an assembly guy, so I love like core, low-level stuff.
Okay.
So,
Well, maybe you can come and help in the background for episode 10 or 11. Let's
I
see.
will do. But I'm not going to be far.
Maybe Lee can get sick. No, I'm kidding. You cannot. get
No,
sick.
Lee. Please, yeah.
Awesome. Thanks everyone for joining. This has been a Build on Serverless, and I see you, not watch you. I see you next Wednesday around the same time. Thank you very much.
Thanks, everyone. Take care.